Hi, I'm Jason Howe, and today we'll be talking about catalysis. So first we'll go over some important definitions, then go on to examine the two different types of catalysts, which are homogeneous and heterogeneous, and finally we'll go over an AP problem that puts these concepts to use. So first we'll move on to the definitions. A catalyst is a substance that changes the speed of a chemical reaction without undergoing a permanent chemical change itself. And it usually lowers the activation energy, which is the minimum energy needed for the reaction, and it's abbreviated by EA. Finally, adsorption is the binding of molecules to a surface. The first type of catalyst is called the homogeneous catalyst, which is a catalyst that is present in the same phase as the reactants in a reaction mixture. So we look at the overall equation. Hydrogen peroxide decomposes into water and oxygen gas. Then we can look at the graph and see that it's plotting energy with respect to reaction progress. So the uncatalyzed reaction is represented by the blue line, which clearly shows that more activation energy is needed to start the reaction than the catalyzed reaction, which adds bromide ions and therefore decreases the activation energy. Now you see that there's two bumps in the red line, and those both represent the first and second steps of the catalyzed reaction. Now we'll take a look at a short animation depicting this catalyzed reaction. The next type of catalyst is called a heterogeneous catalyst, which is a catalyst that exists in a phase different from the phase of the reactant molecules, usually in the solid state. We look at our catalyzed reaction. Hydrogen gas is added to C2H4 ethylene to produce C2H6 ethane in an exothermic reaction. Now, these molecules adsorb to a metal surface, usually palladium, platinum, or zinc, which breaks the HH bonds and then binds the H plus ions to the C2H5 molecule. So therefore C2H6 is produced. We'll take a look at a short animation depicting this. As you watch this animation, notice that the hydrogen ions move along the lattice points of the metal molecule to bond with the ethylene molecule. Finally, we'll move on to AP problems involving catalysts. Now, there's really only one type, which are the rate determining problems. Now, we know that the overall rate is equal to the rate of the slowest step, and we know that catalysts produce several steps in a reaction. Therefore, if the first step is the slowest, then the overall rate is equal to the rate of the first step. If the second step is the slowest, then we go through a whole different process, which involves a little bit of basic algebra. Now we see that 2 moles of nitrogen monoxide gas reacts with bromine gas to produce 2 moles of NOBr, or nitrosyl bromide. We're also given the 2 steps of the reaction, and we know that the first step is faster than the second step. Therefore, we can set up our rate overall as a constant times the concentration of N2O2 times the concentration of Br2. We also know that at equilibrium, the rate of the forward reaction is the same as the rate of the reverse reaction. Therefore, we can set up an equality that is shown in the slide. Finally, we need to solve for N2O2, so we divide the two constants. Now, we must take into account that constants are constants. And no matter if we multiply them or divide them, they will still be constant, so we just leave them as K. So then we substitute and find out that the concentration of N2O2 is equal to a constant times the concentration of NO squared. Now that we solve for the concentration of N2O2, we can substitute everything back into our first R overall equation. So then we get that the rate overall is a constant times the concentration of nitrogen monoxide squared times the concentration of bromine. So that concludes our presentation on catalysis. Thanks for watching and have a great day.